everybody, Marcus here. We are here to talk about fountains today and let you guys know how we put this into our holiday display and let you know how we built it in case you want to put it in your display, either exactly like this or a version of it. We just want to share with everybody. So what we're going to be showing here is one full assembly of 3 nozzles and 3 lights. We have 2 of these in our display to keep it symmetric, one on the left and the right. So basically what we have going on here is for every light and nozzle combination, there's 1 sprinkler valve. We'll get to the model number of these and where to get them in a second. But 1 standard sprinkler valve from a hardware store, and then 1 jet nozzle. Everything else that you see here from the water side is basically just supplying your well or city water pressure to the inlets of the valves. That is one important thing to remember. We do use city water pressure. There are other ways to do it, including well water, but you want to make sure you check your pressure before you look to do this in your display. Our display ran at about 60 psi. 60 psi is our normal water pressure when we're not using any other water in the house. When we talk about the nozzles and how to adjust those, we'll cover how a lower water pressure could still work for what we're trying to do here. So the main thing to remember when using water in your display is to do testing beforehand, before you build your assembly, and note that the most important thing is that you use the least amount of water but maximize the look, because this is going to be at night. So if the light doesn't light up the water, it's not going to be worth it. So that's kind of how we developed this very simple method, was testing at night and understanding what different lights did to light up the least amount of water. So what we found, these lights, there's not a specific model number. These all come from China. I found they are available very regularly on eBay. If you search 45 degree PAR, P-A-R, which is the type of reflectivity in the lenses. So 45 degree PAR light. These lights do tend to come up on eBay and are readily available for anywhere from $60 to $100 a piece. Other lights are possible. You just want to make sure not only are they outdoor rated, but you test one of them before you decide to use it, considering that water sits on there every night for multiple hours. These particular lights, if you do decide to go with these models, are just DMX controlled. We'll get to the plugs and how the plugs work in a second, but let's talk water first. So our nozzle approach here is very simple. This is a Orbit 3/4 inch valve available from Lowe's. We'll show you the package here in a second. No flow control on the inlet side of the valve. We are using raw water pressure from our city water supply here. Like I said, it's about 60 psi, but from my estimations, if your house was lower down to about 40, that would still be okay. And here's why. The secret really to how this looks in our display and how we're able to get the water to fan out and the light to actually light the water up, the secret is really in this $3 component here. This $3 component is called a jet nozzle. It's also available from Lowe's, and it has a ball valve inside of it. And so while the purpose of this jet nozzle is to basically act like a cheap pressure washer for your hose, what the ball valve does is if the ball valve is all the way open, this stream is going to be very, very narrow. But what we've done is we've adjusted to about 40 to 50% on the ball valve. And what that did, it surprised us in our test. We really weren't expecting this, but it creates vibration of the water and it fans out coming out of the nozzle ever so slightly and creates almost like a very small flowering effect. Again, in your testing, you can see where you need to adjust these, but it wasn't an exact science. All of these are not exactly the same, but within about the same range, they'll create that slight flowering effect. I know some folks have been wondering the distance that I used. The distance from nozzle to nozzle, I used 16 inches. We found that going any closer than 16 inches, there was way too much bleed from light to light, when you were trying to do like nozzle number 1 is green, nozzle number 2 is red. There was too much bleed when we went closer than 16 inches. So that's what I advise there. Let's see. What else about the water? Again, like I said, we ran 6 total nozzles in our show. We did test it out, turning the shower on during the show, starting the washing machine, and really the only effect the viewer of the show never really would have noticed, but the height of the sprayers was just a little lower if we were, say, starting the washer. So it's going to be different for everybody in how your system handles the pressure. City water the pressure is going to recover almost immediately, whereas well water, it might take a second more. So before you do a build like this, grab a couple parts at your hardware store, nozzle, valve, test it out on your hose just to see what the effect would be if you actually decide to build the fountains. So before we move on to the lighting and electrical piece of it, let's take a look at that valve like I talked about. So again, I use the Orbit brand. There's no reason you can't use any other type of valve. It is worth noting that Orbit switched over to this style valve from what's called the jar top valve, which was their older style. There's no reason the older style might not work, but just if someone's trying to replicate this exactly, I had no problems with these valves throughout the whole holiday season, and they're cycling constantly. If any of you have seen the demo video, these things are constantly going off for 4 hours a night, and I had no damage throughout the first season. So, and again, 3/4, no exact science to that, except it's very easy to get 3/4 parts. There's no reason you can't use a 1 inch as well. Okay, and here's a look at the jet nozzle. Again, available at Lowe's. Both these items are available at Lowe's. If you look inside, you can see that ball valve that I was talking about, and how when adjusted at about half, you can see the ball valve creates that turbulence. Okay, and then the last thing I'll talk about is water distribution when it comes to the actual water pressure. So like I said, we have 2 of these assemblies in our show. Each one feeds from a standard hose connection. And again, all these pieces of PVC are just standard PVC pieces, and this will look different for your display depending on how you build these and where you put them. But basically we had 1 standard hose inlet for each of our assemblies, and that hose ran all the way back to the hose bib, to the source. And then at the source, I personally used a 4-way splitter to feed both fountain assemblies. And then to monitor my pressure, since this is the first year I did it, I used a $10 pressure gauge from Lowe's just so I could see what would happen when the fountains would go on and off. Okay, I guess the only other thing I'll add, play with valves, play with nozzles. You'll notice I didn't put any kind of flow control valve. I believe I said this earlier, but on the inlet side of the sprinkler valve. That was on purpose. When we did that and we lowered the pressure coming into the valve, we weren't able to achieve the flowering effect. The flowering effect really took that full 40 to 60 PSI coming into this valve and then flowering up. So it may be a little different for you. If your water pressure is very, very high, you may need to put a ball valve ahead of the sprinkler valves. But again, just play with it before you build it. Okay, we will talk in a second about how I use a Christmas light system to control these valves as if they were an AC channel. But let's talk about the lights first before we move on to the control. So here's a light. Like I talked about, if you search 45-degree par light, they're outdoor rated. They held up through the rain. I kept them in the Florida summer rainstorms for a couple months to test them out. They're built very well. So let me show you what's going on in the back. So basically every light has 2 inlets and 2 outlets, 1 DMX in, 1 DMX out, 1 power in, 1 power out. So from a power perspective, I am daisy chaining these from left to right, and basically let's look over at our assembly. So if we look at the assembly, there's a standard plug, and I have a waterproof box, Basically what this waterproof box is doing is taking power that's always on from your display, so not controlled power, but always on power, and then inside of this box, actually plugging in the whip that comes with the lights to power up the chain of lights. So let's take a look at our sample light over here to show you. These lights, so they come with what appears to be an outdoor XLR or X-Connect connector, and it comes with adapters that adapt it into something familiar, right? So this right here, this whip, is all that's in that gray box down there. That's all it's doing, is feeding constant power to the chain of lights. And then each light uses the power out whip and goes over to the light next to it, and you can see those connectors right here. So one connector on both of those is the power feed that daisy chains from light to light. So the power is pretty easy. Let's talk about the DMX. Everybody's display is going to be a little different. I'm sure all of you are familiar with DMX networks. These are standard RGBW DMX controlled. So basically all you need to do is take your first light in your chain of DMX and hook it up to wherever the closest DMX is, and then map that in your show, whether X-Lights or Lightorama. It is just standard DMX. The menu is very simple on these lights. If you happen to use them, you set the starting address on the back, you're good to go as far as DMX. So let's look at my box here, and we'll talk about in a second how the relays are controlled. But I want to show you the DMX pin out. So basically all I did was take that DMX male lead from the first light in the chain, connect the whip that came with the lights, which comes out to a male XLR, and then just hooked up a female XLR, cut the end off, and hooked it up into my display with whatever wiring that you have available to you that goes to a DMX port on, be that a Falcon controller, be that a raw DMX network on Lightorama, whatever DMX is available to you, these lights are just standard DMX. Okay, so I think that covers lighting. Before we forget, we have one more thing. One more question that I was asked was the spacing between the nozzle and the light. Again, this was all tested, tested proof of concept wise, and we just built kind of how we tested. About 7 inches from the actual jet nozzle head to the center of the light is what we came up with, and then we slightly tilted the lights. This is not the only way to do it. They can be extended out a little further, but I guess my main point here is that the center of the light is very close to the nozzle. It's basically about as close as it can get. And with a 45-degree throw light, you're definitely going to want to do that, or you're going to be wasting a lot of light and you're not actually going to light up the flowering jet of water. So just wanted to share that spacing before we moved on. Okay. All right, so the last topic to cover that I know a lot of you had questions about was about how to actually control these in your light show. So those of you that have done sprinkler work at home or are familiar with different power supplies, different voltages, these sprinkler valves are designed from a voltage perspective to work on a standard sprinkler system. A standard sprinkler system is 24 volts, but it is 24 volts AC, right? So your pixels are 5 or 12 volt DC. These are going to be completely different. These are 24 volt AC. They do make valves that are not 24 volt AC, but to keep the cost down and for simplicity, we're just going to use these ones from Lowe's. But that does mean that you need to be a little careful in how you control these and how you wire them up, and be very, very cautious about making sure you have the right voltage available to control these. So from a wiring perspective, basically all that's happening here, there are 2 wires coming from every one of these valves. The valve is closed unless 24 volt AC is present on these 2 wires here. My little box that I pinned out my DMX here, all this is doing is taking all my 3 valves, putting them inside of a watertight box, and allowing me to take my cable from my fountain control box and connect it up to each pair of wires. In my specific display, my wire runs weren't that long. I did use a Cat 5 cable because it was available to me and I already had a spool of it. These don't draw much power at all. They barely draw any power, but you do need to be careful not to use anything too thin. It is noted that when I did use a Cat 5, I doubled up on the pairs. So like if for example, this would use a blue and white blue, and this would use a brown and a white brown. So it twisted those pairs together in order to make sure I had a thick enough wire to actually pass the current. So that's all that's happening here. Is this box is basically just pinning out my, okay, let's call this valve number 1. It's not really positive and negative because it's AC, but valve number 1 and valve number 1A and B. And then everything else happens on what I built and call a fountain control box, and it's what actually turns these wires on and off and activates the valve. We'll go take a look at that. Okay, this is where the solution for your display is going to be much different depending on what kind of controllers you have already, whether you're in Light-O-Rama or X-Lights, whether your entire display is pixels, whether you have any AC controllers. I'll show you the way I did it, and always available to answer questions about your specific show, but I'll give you a general overview of how I did it. First of all, I talked about 24 volt AC. We all know that this plug coming out of your house is 120 volts AC. We need 24 volts AC, right? So instead of talking a power supply, I know a lot of you use like HP power supplies, that converts to DC, right? So we need a transformer that transforms 120 to 24. I chose this model. You can get these for about $30, $40 on eBay. It's a company called Ultronics, and the model number is ALTV244. I chose this model because it can handle a couple amps. Again, it's a little bit overkill, but it's so cheap and they're very well made that I use this product. There are a lot of plug-in little wall adapters or little black transformers with an extension cord on them. There are a lot of other ways to do this, but this is the model I used. Okay, this is my fountain control box. So the way that I achieved turning these on and off was using the outputs from a Light-O-Rama AC controller to trigger relays. Okay, so a relay, for those of you not familiar with a relay is basically a physical device that when it sees a certain voltage on the relay coil, it activates a physical switch inside of the relay that connects two things. It's almost like the toggle switch that you use to turn on lights in your house, but it's doing it when it sees voltage on something and it's doing it for you. It's moving it for you. So basically what I'm doing here is I'm saying, here's a 24 volt AC transformer, and here are all my relays. When I activate an output on my Light-O-Rama controller, it's activating a relay. The relay is acting like the toggle switch, and the relay is toggling on and providing 24 volt AC to my valves. Again, there are a lot simpler ways to do this. There are some DMX boards that are made specifically and have relays on them. That literally you could map to a DMX channel and say, hey, when I turn on, in Universe 1, when I turn on channel 1, it will turn a relay on, and that relay is my toggle switch that provides 24 volt AC to a sprinkler valve. So again, this is the part where it definitely will vary show to show. I will make a quick wiring diagram and make that available for folks that want to do it exactly like this. Another example that I'm helping some folks with is using the Pixel to Things by David Peace. Those boards, the Pixel to AC boards, you can do the exact same thing. So if you have an all pixel show, you can use a Pixel to Things board as well to trigger your valves. So yeah, that about does it. I know some folks too have asked about timing when it comes to when do you turn these on? Is there a delay? The delay is very, very slight, meaning that let's say you have an AC channel in either X-Lights or Lightorama. When you have an AC channel and you turn it on, this valve turns on almost instantaneously as far as the eye can see. What's not intuitive and what you have to play around with as you're sequencing your songs is when do you turn the valve on and when do you turn the light on? In our example, on our demo reel of fountains, we have examples of both, but you wouldn't necessarily see the example because it differs per song and what effect you're trying to achieve. The best way I explain our process was you want to see it one of two ways depending on what you're trying to do. Sometimes you want to turn the light on first, then activate your valve. So if you're looking at your sequence in time, you would say, okay, DMX light number 2 comes on now, and then right after that, valve number 2 comes on. That way your light is on to see the water shooting up, and the viewer really sees the water coming out. The other effect you might want is you might want to turn the light on after the water is already shot or coming back down if you just want to see the water falling back down. So it's really just up to you to play with while you're sequencing. And so I always suggest before you do this, do it early, do it in your backyard and play with it at night. That's how we came up with how it looks in the final show. And once you play with it once, just like anything, just like with your pixels or your AC lights, once you see how it looks once, then you know how to sequence it. So that's kind of the two means and methods that we learned while playing with it was when to turn the nozzle on and when to turn the light on. That's really what you're going to play with the most. And then timing is forgiving when it comes to this, just because the effect is a bit variable in terms of water flying up in the air when you turn your light on, etc. So I think the last thing that I'll leave you with is we're talking about sequencing these, and you can see this in the demo. The most startling and really cool effect that we found these work the best in is if there's no light on behind them. So think of where you're going to put these in your show. Think of if they're in front of your house. Think of any lights you have in your house, any bushes, any props that would be behind this. And think about the washout that will cause. It'll basically not allow these lights to do their job in lighting that water that you're shooting up, and you really lose the effect. So make sure when you use these, it's a dramatic effect. You turn off anything behind these, and then also make note of what color you're using. And make sure it's, we found it was very dramatic if it was a contrast of everything that's around it. Think your whole yard, pixels, AC lights, whatever they are, your whole yard's red. These guys pop up and they're green. It's startling. You notice the fountains, you focus on the fountains, and they look really cool. So anyway, that I believe is about it. The last thing I want to cover before I leave you, and again, please let us know if you have any questions. We are The Holiday Show. If you find us on Facebook, The Holiday Show with no spaces. The last thing people have asked about is, does this flood your yard? How do you do this with electricity all over the place? Do note, we are in Florida, we're on a ridge, we have sand in our yard. Our yard is basically sand. We are lucky that all the water that we shoot up, we use a couple 100 gallons a night, running the show for about 4 hours, but we do have a lot of fountain cues in our show. But the sand just takes all the water and brings it right back down into the ground. So we don't have that problem. We also don't have a lot of grass right there for the water to get caught up in the roots. So do make sure that if you do have a thicker yard, no sand, do make sure you think about that before you put water in your show. And from a cost standpoint, also think about if you do pay sewer costs on your water supply if you're using city water. That can shoot up very quickly. We thankfully have septic here, so our water bills are very low because we don't pay sewer on them. But I've talked with folks about if you have the purple piping, the reclaimed water for irrigation that you don't pay sewer on, and you're comfortable with some plumbing, you can definitely tie this into your irrigation system and use this just as if it's a sprinkler. Because at the end of the day, it is kind of a sprinkler. So says that green patch in our front yard. Anyway, thank you for tuning in, and if you have any questions, let us know at The Holiday Show.